So hello everyone, today we will be solving the question symmetric tree. So the question says that given the root of a binary tree, check whether it is a mirror of itself, that is symmetric around its center. So basically what it is trying to say is whether our tree, if our tree is divided into two parts from middle exactly, then we have to check whether the left side of the binary tree is mirror image of right side or not, which means basically here it's 3 4, so mirror image of that will be 4 3. Similarly here the left, so in simple words we can say that for a subtree to be binary, then any left of its node should be equals to right of its node. For example, here if we take 2 as example, the left of the node is 3, so in mirror image for 2 the it should be right of the node. So basically this is the whole base of the solution, that is for any node, if it is a left of its, if we go left to the node, then in mirror image it should be in the right. So let's first write the base condition, that is suppose if our node is empty, so if our root does not exist, then I'm just gonna return true, because it's already going to be a symmetric tree because nothing exists. And what we need to do for each node, its left should be equal to right. So basically we need to compare its left and right. So let's make a function and we'll return it. Make a function that's actually gonna compare the left and right. So it will compare root left and it will compare root right. So let's write the function. The function would be bull as mirror. What should be the parameter? Suppose the two nodes, that is left and right, so I'm just gonna write it tree node, I'll just left and tree node right or, and let's just solve it. So what I will give some condition that for it to satisfy left and right, first the node should be same, because suppose if it's here 3 and if it's here suppose it's here 2, then here it's here 3, then the both nodes are unequal and there will be no scope of comparing that it's left and right. So we can just write that if left if not is equals to right, then we are just gonna return true. And if similar to this, but here instead we'll use or, that either one of them does not exist. Okay, so what first line says is that suppose left node also doesn't exist and right node also doesn't exist. That means we have reached the end part, and if we have reached the end part and which means that all the previous attempts were true, which means we just need to return true. But here suppose if 1 is not equals to null and 1 is equals to null, which means there's a unequal node, so we just need to return false here. Now let's look at the important case, that is if they are not even equal, that is if that value is not is equals to or a value, then uh, we just simply return false. There no need to check left and right. Now suppose if it happens to pass all these tests, then we will return as mirror. Now we have to check for left and right both, so I'll just take both. Here it will be uh, left, and here I'm just gonna be right. So left is equals to right, and alpha right should be equals to alpha left. So this was the whole logic of this, that for a node left should be equals to right and right should be equals to left. So let's try to run it and let's see if this works. Yeah, it works. Let's try to submit it. It passed all the test cases. So yeah, thank you for watching this video. Bye.